Alright, let's look at this Unit 3 test review. These first 5 questions, are asking us to solve the system of equations by graphing. So one thing you really should have when you're solving by graphing is a ruler. You really need a ruler, especially if you're solving systems of equations. So let's just look at number 2 first. So we have these equations, they look kind of funky. Really, you want them either in standard form, or you want them in slope-intercept form. Standard form looks like this. Oh, sorry. And then slope-intercept form is y equals mx plus b. I prefer slope-intercept form. So naturally, we'll do that with the first equation here. All we need to do to get it in slope-intercept form is to divide both sides by the coefficient on y, which is -8, so that y is by itself. So -8y is equal to 3x minus 48. Once we divide by -8, these cancel, and we have y is equal to -3/8 x plus, because a negative divided by a negative is positive, and we get 6, right? Okay, so we know the y-intercept is 6, and we know the slope is down 3 to the right 8. So down 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, 8. So here's that point, and when I have this straight edge, and I actually use it, get as clean of a line as I can. This will help in getting the solution to this system, because I'll know exactly where those intercepts are, or the intersections are. Alright, let's look at the second equation. We'll try out standard form. All we need to do to get to standard form is subtract both sides by 7. So I'll do that in one fell swoop. This ends up becoming that. And what's nice about standard form is you can find the x and y intercepts just by, basically I'll do this. I just got rid of the 2x. What's my y-intercept? It's -7. So I'll plot that. And then I'll block out my y. My x-intercept is the x value that will make this statement true. So I'll just rewrite this. It's 2x equals -7. If I divide both sides by 2, I get x equals -7 halves, which is 3.5, -3.5. So that should be right here. Alright, now if we connect these 2 points as cleanly as we can, there we go, almost there. And here we go, this intersection is -8, 9. This is 9 right here. So we know our solution is -8, 9. So that's how we solve systems of equation by graphing. The first part involves rewriting the equation so that you can graph it. The second part is finding where they intersect. Now if they don't intersect, let's say you get 2 lines that have the same slope, you guys know how many solutions there are there. Since there's no intersection with parallel lines, you have 0 solutions. The only other case is when you have lines that overlap, or they're the same equation, you have infinite solutions. Okay, let's look at solving each system by substitution. So these ones look nice because they all already have an isolated variable, and that's really what you want. So there's an isolated variable there, there it is there, this one isolated, and this allows you to just plug in what that's equal to. So it looks like in all these cases we already have an isolated variable. It could be x, it could be y. In this case, I'll just do number 9. We look and see that y is equal to negative 3x plus 13. That's what it's equal to. So what I'll do is take the other equation, and instead of writing y, I'm rewriting it, but I will, in parentheses, rewrite y, but I'll be writing what it is equal to, like so. Now just make sure if you have a negative in front of it, or a negative with a number, like -2, that you distribute. Negative times a negative is a positive, so negative x plus 3x, a negative times a positive is a negative, so you get negative 13. Now if I combine like terms, I get 2x, and if I add 13 to both sides, I get 2x equals positive 10, so x equals 5. Now what I can do is say my solution is 5, comma, now I just need to find my y value. But since I know what my x value is, I can rewrite the easier equation, negative x minus y equals negative 3, and plug in 5 for x. What I'll do is add 5 to both sides, and I will get negative y equals positive 2. If I divide both sides by -1 or multiply both sides by -1, I'll find that y equals -2. So here's my solution. I'll just highlight it. Good, so that's by substitution. If we're going to use elimination, there's the easy case in which when we subtract or add one equation from the other, automatically we get rid of one of the variables. Doesn't look like we have that for any of these equations, so this is more on the tough side. So let's see, let's do whichever one. We'll do 12. Okay, so we have negative 30x plus 15y equals 0. This one, let's see, what's the easiest way? We need to make sure that the coefficients on one of the variables are exactly the same. So negative 30 and 12. I think the easiest way to do this one is to, let's see, maybe we'll change this by dividing by -3. So we get 10x plus 5y equals 0. And then, for this equation, yeah, these are definitely the tougher ones. We can do, which one can I get rid of? I'll just keep this, 12x minus 6y equals 0. And I think the easiest thing to do here is to multiply, I'm going to get rid of the y. So what I'll do is I'll multiply this one by 5, and multiply this one by 6. So that we end up with 30y and negative 30y. So when I get this, just remember to distribute to each term. So I get 60x plus 30y equals 0. And then when I do this second one, I get 5 times 12, that's 50 plus 10, so 60x, oh man, look what happened, minus 30y equals 0. And if I add one to the other, or subtract one to the other, it looks like I got the same values for x and y. So we get, we'll subtract. 60x minus 60x is 0. 30y minus negative 30y is positive 60y. So we divide both sides by 60, we get y equals 0. So our y value is 0. And then if we plug that in for either of the equations, maybe we'll do the second equation. 12x minus 6y equals 0, where y equals 0. 6 times 0. We get 12x equals 0, so x must also equal 0. So if you were to graph these equations, you'd have something where they intersect at the origin. I don't know what the slopes would look like, but that's essentially what it would look like. Let's look at a different one. Okay, how about that first one? I'm guessing the first one actually has a good solution. So here we go, negative 6x plus 5y equals negative 14. We'll get 2, value 2, for example. No, we'll go to 12. So we'll multiply this one by 2, and we'll multiply this one by 3. So in the first case, I get negative 12x minus 10y equals negative 28. And then for the second one, I would get 12x plus 12y equals 36. So notice the coefficient here is the same number. Since one of them is negative, I'll just add the two equations. So negative 12x plus 12x is 0. And then we get negative 10y plus 12y is 2y. And then if we combine these, we get the 8. So y equals 4. And then if we need to find our x, we can just plug it into any of these equations. 4x plus 4y, which is 4, equals 12. We get 4x plus 16 equals 12. Subtract 16 from both sides, we get 4x equals negative 4. Therefore, x equals negative 1. So here's our solution there. And I'm out of time on my recording.